focus today is called the potatoes. And the problem is, why is A equal to 63 millimeters, but B equal to 57 millimeters? I'm gonna show you two pieces of potato. They're in these jars, A and B. One is 63 millimeters long and one is 57 millimeters long. You may not be familiar with the term millimeter. A millimeter is about the thickness of a dime. So if you had 63 dimes stacked up, it'd be about that long or that high. I'm going to take the lids off these jars and show you the potatoes. There's a potato in each one that looks a little bit like an uncooked French fry. But you'll notice right away that they're different lengths. Here's A, that's 63 millimeters, and here's B, that's 57 millimeters. Well, there's a reason for that, and it's the manipulated variable. In every scientific experiment, you have a control group, which in this case is A, and you have an experimental group, at least one, in this case it's B. And then you treat both of them exactly the same, but they're different in only one way, and that's the manipulated variable. So A and B are exactly the same, except that the manipulated variable has been applied to B. So it's up to you to gather enough data to decide what the manipulated variable might be that causes each to be different lengths. If you have a data question that might help to answer that, raise your hand. You can either ask a question about the jars, the liquids, or the potatoes. Any of those. Jeremy?
Are the potatoes different kind of potatoes?
I'm going to make that a little simpler, Jeremy. Are the potatoes from the same potato? It's getting at what you're driving at, but it'll eliminate some other questions too. Are the potatoes from the same potato? Yes. And I misspelled potato. Yes, they're from the same potato. Okay. So is the potato the manipulated variable? No. But we didn't know that until Jeremy asked about it. So what would you like to know, Stevie?
And liquid A and B, are they the same?
Are liquids A and B exactly the same? I'm putting the word exactly in there because if there's even one difference, then we'd call them different. No, they're not exactly the same. So now we have enough data for a tentative conclusion, but it's only tentative. Don't write it down until I tell you it's final. Here's what we can say so far. Because liquids A and B are different. That's supported by those data, and it's not refuted by those data. Who remembers what refute means? If you refute a conclusion, what do you do to it? Jessica?
It's like something about false.
You prove it false. Well, those data don't prove this false, and they support it. So we would call it valid, comes from the Latin word for true, or reliable. But it's not good because it doesn't tell you how to set it up. A good conclusion would tell you how to set it up, and that doesn't tell you enough. So we know that the liquids are not exactly the same. All right, who thinks they know what we should ask next, Darby?
Does liquid A contain only water?
Let's find out if it has any water. Does liquid A contain any water? Does it look like water?
Yeah.
Does it look like water?
Yes.
Does liquid A contain any water? Yes. All right, who knows the control question for 3? Control, Jackie,
Does liquid B control any
does
water?
liquid B contain any water? Yes. Is water the manipulated variable? Why isn't water the manipulated variable? Why?
Because they both have it.
They both have it. Okay, good. Now, what's the next question we need to ask about A? Darby, you know.
Does liquid A contain only water?
Good. Contain only water. Yes. All right, now somebody I haven't called on, tell me the control question for number 5, Brandon.
Does liquid B contain only water?
No. Okay, now we have some additional data, so it's possible to add to the conclusion, like a good scientist does when he gets more data. I'm just gonna put A because we know we're talking about the liquids now. A is only water. But B isn't only water. That's not very specific, but it's better. It's better than it was because it's supported by more data. Okay, so we know that B isn't only water. Who can think of something that ought to be asked next? What did we find out next, Wyatt?
Were the potatoes at the same length?
Oh, well, okay. That isn't what I had in mind, but that's a good question. 7, were the potatoes cut the same length? All right, now there's a reason that's related to the scientific method why you should all know the answer to this. Were the potatoes cut the same length?
No.
How many say no? How many say yes? Yes, the potatoes were cut the same length. Why should you know that? It's related to the scientific method. Harley?
Because he would tell us that or else it would.
Yeah, well, that's a creative answer, Harley, but that's not it. Who can tell me in one word what the manipulated variable in this experiment is? What? The liquid is a manipulated variable. Something about the liquid is a manipulated variable. Then why should you know that the potatoes were cut the same length? Why should you know that? Wyatt?
Because we could have just tricked us.
What would you have in the experiment that you don't want to have if the potatoes weren't cut the same length? You'd have 2 what? Who knows the answer to that? You'd have 2 what if they weren't cut the same length? Do you know, Tanner?
2 manipulatives.
Yeah. You'd have 2 manipulated variables, the liquids and the potatoes. So you should know from the scientific method that those potatoes had to be the same length at the start. Now, I understand why you're a little bit confused because the potatoes aren't the same now, right? But they had to be at the same at the start, or we would have had 2 manipulated variables because we know that the liquids aren't the same. Okay, we're going to pursue that again. But we can pursue this and then come back to the other one. They were the same length at the start. Were the potatoes cut blank millimeters? Yes. Now you could put just about any number in there and it would be a possibility. But there are only 3 numbers that are logical to put in there. Who can figure out a number that would be logical to put in there? Emily.
63.
Why is 63 logical, Emily?
Because A is 63 and
One of them is 63 now, so maybe they were both 63 and B shrank. Okay, that's one possibility. Who knows another possibility? What's another one, Jonathan?
they could be 57
Why is it logical that they might have both been 57?
because A got bigger.
Okay, maybe they were both 57 and A got bigger. Those two are fairly obvious because those are their lengths now. But there's another length that's not quite so obvious that they might have both been. Who knows a length that they might have both been, Jeremy?
60,
Why is 60 logical?
because it would, like, A could have, since it's, liquid A isn't, that, I think it will anyways, it could have, like, grew bigger, 3 millimeters, and, B could have shrink.
Okay, now what's another way of explaining it besides Jeremy gave a very long answer? Why is 60 logical? Who can think of a simple answer to that? Harley?
Because like sometimes water, like if you get something wet, it kind of shrinks. Like
Well,
if
that's
you
not
get
very
like
simple.
a paper towel wet, it like
That's a complicated answer. What's a simple answer, Jonathan?
um
Why would 60 be logical?
because it's 3 apart.
Because it's in the middle. Okay, that's what Jonathan is saying. Now Harley wasn't wrong and Jeremy wasn't wrong, but I was looking for a simpler answer. A lot of people make science way too complicated. Okay, so here's what they were. They were both 60. All right, I'll go up here where you can see it better. They were both 60, so that calls for 2 more questions. 9. Did A blank? Yes, that's a verb that goes in that blank. 10. Did B blank? That's a verb that goes in that blank. Who knows what A did? What did A do, Kendall? I thought you had your hand. Oh, okay, Jessica.
It grew.
Did A grow? Yes. All right, who knows what B did? What did B do, Janelle?
Shrink.
B shrank. Did B shrink?
Yes. Yeah.
Yes. All right. Now, does anybody know why B shrank? No, at this point you don't know because you don't know the specific manipulated variable yet. You know that the liquids are different. So, we know that A is only water. You know that B isn't only water. So what should we find out about B now? Allie,
What else is in it?
what else is in B? Okay, does B, we're talking about the liquids now, does B contain any blank? Yes. All right, here's some clues. Don't say a substance until you have enough clues to identify it specifically. It's a solid, it's granular, it's found in the kitchen, it's white, and it's not sweet. What does it have to be, Chase?
Salt.
Salt. Okay, now, does B contain blank, 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 salt, and water? Raise your hand if you know what word goes in the 4 blanks. What word goes in there, Justin? Only salt and water. We have to find that out before we name 100 different substances that might be in there. Let's find out if it's only salt and water. Yes. All right, so now A is only, I can change this, A is only water, but B is only salt and water. Okay, it's getting a lot better now. In fact, there may be enough information there that you can figure out how to set this up. Raise your hand if you think the salt had anything to do with B shrinking. what is it about the experiment that tells you salt must have had something to do with with bee shrinking, Darby? What is it about the experiment that tells you it?
A contains water and blue. So,
But what is it about the experiment? You just explained why, possibly why A grew. Why did B shrink? Why do you know that the salt has something to do with bee shrinking? Okay, A doesn't have salt and B does. No salt, it didn't shrink. Salt, it shrank. So logic tells you that the salt must have something to do with it shrinking. All right? Raise your hand if you know of anything else that shrinks when you put salt on it besides a potato. Who's ever seen anything else shrink when you put salt on it? Tanner?
A slug.
Raise your hand if you've ever seen a slug shrink when you put salt on it.
I've seen it.
All right? The slug shrinks for the same reason that the potato shrinks. It's the same reason, but I doubt that any of you know, so I'm going to discuss that. Now, it's a very important biological process that's going on in your bodies right now, in all of your cells right now. And it has that many letters, but I doubt that any of you would know the word. I think some of you have heard the word, but I've never yet found a fifth grader that knew the word before I told you. But I'm going to give you the definition of that process. It's the movement of water through a membrane, and I'll explain what a membrane is, from where it is more pure to where it is less pure. Okay, I don't expect you to understand that until I draw 3 potato cells to illustrate it, and then I think you'll understand it. Does anybody know what that process is? Well, let me explain what a membrane is. It's always the movement of water. It's always through a membrane. A membrane is something that allows liquids to pass through, but not solid. A coffee filter would be a membrane, but it's a very coarse membrane. A better example of a membrane is when you crack an egg into a dish. Have you ever noticed that the yolk is nice and round if you crack it carefully?
yes.
Okay, have you also noticed that if you poke the yolk with a fork or a knife, the yolk oozes out?
Yes.
You ever noticed that?
Oh.
The reason the yolk is in that knife